So this video is going to take one step further into our exploration of stoichiometry. Last week we talked about mole-to-mole stoichiometry. Now we're going to add grams to this. So we're going to use mole to gram and gram to mole stoichiometry. So the first question says, in photosynthesis, plants use energy from the sun to produce glucose C6H12O6 and oxygen from the reaction of carbon dioxide and water. So we'll put our equation here. So we have CO2 and H2O will produce glucose and O2. Now we need to make sure we balance this. Okay, so the question says, what is the mass in grams of glucose? So question mark G is produced from 3 moles of water when it reacts with carbon dioxide. All right, so we're going to write down what we know. We know 3 moles of H2O. All right, so we're at our easy pass station. We want to go over our bridge since we're in moles of our initial reactant. And we want to go to moles of glucose. So 1 mole of C6H12O6 all over 6 moles of H2O. Now, we want to go from moles to grams of glucose. So we calculate the molar mass of glucose. So we have 12.01 times 6 plus 12.12 plus 96, which will give us 180.18 grams of C6H12O6. So we have 3 divided by 6, hit equals, and then times 180.18, and we get 90.09 grams of C6H12O6. So that's a mole to gram stoichiometric calculation. Now, we're going to do a gram to mole calculation. So it says the first step in the industrial manufacture of nitric acid is the catalytic oxidation of ammonia. So they give us our equation, but it's unbalanced. So we need to balance our equation. So to do this, let's take a look at this. We'll start off, we'll put a 3 here. We'll put a 2 here. We'll put a 2 here. Let's see. So now we have 2 nitrogens on both sides. We have 6 hydrogens on both sides. And now we only have 2 oxygens here and 3 oxygens from here. So that's 5O. So 2 times what will give me 5? 2.5. So I need to multiply everything by 2. So it will be 4. Whoop. Four, 5, 4, 5, 4, 6. Once again, 4, 5, 4, 6. You can always check your work to make sure you have everything correct, which we do. Okay, so it says the reaction is run using 824 grams of NH3 and excess oxygen. How many moles of NO are formed? That's the first question. We know how many moles of NO are formed. So we'll start what we know, 824 grams of NH3. We need to change those to moles to get to our easy pass station. Molar mass of ammonia, 17.04 grams of NH3. Now, since we're in moles of NH3, we can now go to moles of NO. So we have 4 moles of NO all over 4 moles of NH3. So we figure this out, and we get, put it up here, 48.36 moles of NO. Okay, next one. I want to know how many moles of H2O are formed. And we're still going to use the same initial reactant they gave us, constant amount. So 824 grams of NH3 times 1 mole of NH3 all over 17.04 grams of NH3. So the only thing that's going to change here is our mole ratio. So it'll be 6 moles of H2O all over 4 moles of NH3. So 824 divided by 17.04 times 6 divided by 4, and we should get around 72.54 moles of H2O. And this concludes our video on gram to mole and mole to gram stoichiometric calculation.